Hello everyone. Today we'll be looking into doing selections with the Price Active Selection software. First we'll show you where to find it. You go to priceindustries.com, Products, Memes, Resources, Software, the Active Beam Selection Program. Click Download. Once your download is complete, go ahead and open the file. Make sure to enable content when this appears, otherwise your program will not work. Also, the program will ask you to make sure it is up to date, so click Yes. Okay. Now that the selection software is open, let's review some of the features on the active selection sheet. As a quick note, any green cell is an input, while all white cells are outputs. I can type into the green cells, but we'll get an error if I type into the white cells. Light blue text reflects values for cooling, and orange text reflects values for heating. Any red and orange cells indicate we are not meeting our zone requirements. In the top left, we have project details such as name, owner, and project elevation. Underneath, we have our global, room, air, and water conditions. Other features in the program include auto selections, which I will demonstrate. The program also keeps the project totals tallied, such as your total CFM, total GPM, total chilled beams, and total length of beams. This feature is helpful for keeping track of the project totals, as well as comparing different selections in separate windows. We also have small quick tutorials highlighting the features of the program. The Throw Data tab also allows us to check the rows for each beam. And lastly, we have Configure and Quote, which I will be highlighting later. Now let's go into the chilled beam performance data. The performance data is calculated and presented through 5 different fields in the software program. First, we have our global parameters, starting with room conditions. These will be the set points of your condition space. With chilled beams, room conditions are similar to typical HVAC selections: 75 dry bulb at 50% RH for cooling, and 70 to 72 dry bulb for heating. The software is live, so as I make changes to my set point conditions, I will get feedback for my wet bulb and dew point. We also have the option to change the on-coil temperature if you are assuming a temperature difference between the occupied zone and the chilled beam's water coil. We also have the ability to set the noise limit for each beam, as well as the room attenuation, with 10 decibel attenuation being typical. After our room conditions are set, we can look into primary air and water conditions. The primary air is the treated air being ducted from your air handler to the chilled beams. Typical selections for beams having entering air between 55 to 60 degrees Fahrenheit for dry bulb, for cooling, and heating. With regards to relative humidity, depending on which stage of the project you are in, we recommend considering the relative humidity of this primary air so that we can get a lower dew point. Typical selections are done at approximately 50-degree dew point, but with beam selections, we want to reduce the amount of primary air we could typically need down to the minimum ventilation requirements. This means decreasing the dew point in order to get more capacity out of each CFM. We also have the option to limit the static pressure buildup at each chilled beam. Typical selections are done between 0.2 to 0.8 inches of static pressure. Below 0.2, we run the risk of losing induction at the chilled beam. Above 0.8, it becomes a balancing act between high static pressure buildup and noise. And finally, we have water conditions. Typical selections run chilled water from 56 to 58 degrees Fahrenheit for cooling and 100 to 140 degrees Fahrenheit for heating. For the chilled water temperature, we want to make sure we are 2 to 3 degrees above the room dew point for non-condensing applications. Notice how if I type in an entering water temperature below the room's dew point, my cell goes red. This means the beams have a potential to condense in the space. We also have the option of choosing our fluid type and selection of the concentration of glycol. The program also allows us to set a maximum water pressure drop per chilled beam. For the purposes of this exercise, I will reset to our default parameters. Second, on our list of performance parameters, we have our zone requirements. What are the sensible, latent, heating, and minimum ventilation requirements we are trying to meet? These values are typically estimated using a load calculation software. Third, we have total outputs per zone. How are the chilled beams performing from zone to zone? Fourth, there are the selection parameters per beam. These are the values that will affect how each chilled beam performs in the space. Consideration should be given to chilled beam model, whether the system is 2-pipe or 4-pipe, chilled beam length, primary airflow, static pressure, air inlet size, and water flow rates for cold water and warm water. And fifth, all the way to the right, we have individual chilled beam data for both air side and water side. Now that we have a lay of the land of the chilled beam selection software and our global conditions are set, we can do a few example selections. To understand how chilled beams react to each of the separate parameters, we will begin by running a manual selection. We can dive right in and begin inputting the zone requirements. First, for the name, I'll just say Zone 1. Next, we need to put in our cooling, latent, and heating loads. For the purposes of this exercise, I will enter in some arbitrary loads. Let's say for cooling, we have a capacity requirement of 15,000 BTUs. For latent, let's say we have a load of 2,000 BTUs. But notice how when I typed in my latent values, the program immediately listed a minimum air requirement. This minimum air requirement is generated based on my room and primary air conditions. As I adjust my space and primary air conditions, the minimum ventilation requirement adjusts accordingly. I will revert back to the original conditions for this exercise. Finally, I have a heating requirement of 23,000 BTUs. I'll leave my quantity of beams alone for now. Next, I need to select a model type. The program will not calculate any performance unless we choose a model. I will select an ACBL HE24 two-way beam for this exercise. Notice when I selected the model, the program generated performance data. This is not your final selection. We will need to go in and adjust the beam parameters. Remember that the goal is to meet our original zone requirements. Now that we know our model type, we can begin adjusting beam parameters such as length, CFM, GPM, and quantity in order to meet our performance requirements. A good rule of thumb for chilled beam selections is roughly 1,000 BTUs of cooling per foot of beam. So a requirement of 15,000 BTUs of cooling means I need approximately 15 feet of beam in the space. So I will begin with 3 beams, each at a 5-foot length. As I adjust my parameters, I am now getting closer to my design requirement. I need to also make sure my CFM is at least meeting my minimum air requirement in order to satisfy the minimum ventilation rate. The same can be said if my CFM is not helping me meet the latent load in my space. I can now continue adjusting my other parameters until all of my fields are white, which indicates that I have met my design requirements. As a rule of thumb, increasing length, CFM, static pressure, and water flow rates will increase capacity. Once finished, I will look at my additional parameters such as static pressure, noise, water pressure drop, to make sure that they line up with my left-hand global conditions. And this is how a manual selection is done in the selection software. Now we will do an auto selection. We just finished a manual selection which took us a few minutes. The auto select feature is meant to drastically reduce the amount of time required to make selections. I'm going to copy this first line and paste it below so that we can compare a manual and auto selection. Notice that my minimum ventilation value and quantity are now blue. This simply means that these were inputted rather than auto-selected. I will select the same model type. If I do not select a model type, no performance will appear. I'm going to select this line and click Individual Selection. A dialog box should pop up. Here, you can optimize more parameters such as keeping your quantity of beams low or minimizing the amount of CFM you require. In this case, I will auto-select for primary air. I will allow the program to adjust my quantity and adjust my length, and I am assuming the project will have standard T-bar grids, so I only want even length beams. Then I will click auto-select. The program indicates that it has found a solution. And now the auto-selection is complete. Let us compare the two selections. During my manual selection, I chose 3 5-foot beams with 75 CFM per beam and 1 GPM for cold and hot water. The auto-select indicates that I only need 2 beams, each with 110 CFM and with additional water for cooling and for heating. So realistically, I can use 2 beams in this space instead of 3, but will need more on my water side. For beam selections, it is good practice to decrease the CFM needed and put more of the emphasis on the water side. My auto selection should not be my final result. It is recommended to compare the selection to existing layouts and space geometry in order to make sure the selection makes sense. I can further fine-tune my selection as needed to better fit my application. What if I have a project that required multiple selections? I can actually run my auto-select for an entire building if I so choose, up to approximately 300 zones. To demonstrate, I will copy and paste these values from an example project schedule. This project has 45 zones. Doing a manual selection can take a couple of hours. With auto-select all rooms and zones, however, we can get a selection back in a matter of seconds. As mentioned earlier, the auto-select feature typically should not be your final result. We always recommend going in and fine-tuning selections as needed. But in conclusion, we now know how to make selections with the Chilled Beam auto-selection software. Now that we are finished with our selections, let us revisit the throw data feature. If we click this, we are shown a new sheet. This displays the individual chilled beam throw data. These values will change depending on beam parameters such as model, length, and CFM, among other variables. The program can also estimate terminal velocities depending on the space geometry that can be set line by line. This ties back into fine-tuning the auto selections depending on space geometry. So let's return to the selections page. There are 2 additional features we need to highlight. First, we're going to click Configure and Code in the top right corner. This brings us to a secondary sheet. On this sheet, we actually have the option to import our selections into all-in-one for quoting purposes. You have options to select some minor features that are available in the Chilled Beam catalog and submittals. You can also skip this part and go straight into the all-in-one import. A message box will appear. Please read before continuing. This will generate a line string Excel file that you can import into all-in-one. I will save this in the appropriate project folder. Next, I will open up all-in-one, and then up in the top, click Import and click Excel line string import. Then I will go in and select my line string file that I saved in my project folder. Make sure the line string file is not open, otherwise it will not import. Once all-in-one has finished importing, I can begin to further fine-tune my options and accessories for quoting purposes. That about does it for the line string import tool. The final feature on the selection software is the engineer schedule. So let us return to the Excel program and click on the top right for the schedule. This generates a schedule of my selections that I can now use for my engineering drawings and mechanical plans. There are a number of ways to use the schedule for not only drawings, but also submittals. You can print the schedule to PDF directly from this page. First, select all of the cells that are relevant. Next, go to File, Print, and select Print to PDF as your printer. Then, to make sure your page is displayed correctly, select Print Selection Only and make sure to fit all columns to page. You can also choose to display this on letter size or 11 by 17 for drawings. Once you have these configured, click Print and save the document in the relevant folder. And now you have a PDF file to use for submittals. You can take another approach if you want to customize the columns. Just select all the relevant columns. Next, paste them into a new blank Excel page. Now you have the ability to hide and add columns as necessary to best fit the needs of the engineering document or submittal. You can now do the same thing with this new sheet and print to PDF, but now the schedule is more customized. Now that we understand the schedule feature of the software, let's return to the first page. Well, thank you everyone. This sums up the Chilled Beam Selection software. If there are any additional questions, please contact beamteam@priceindustries.com.